Hi, so in this part of the video, we try and explain the code that we have written. So for implementing the inclusive cache policy, by default, when we fill caches, it always fills from bottom to top. So always when there's a miss in the higher level cache, it fills all the caches below it, and then the block is sent to the higher level cache. So we didn't need to change anything in that. The one thing that we needed to change was when a block is evicted from a lower level cache, but it could be present in higher level caches. Since the higher level cache has to be a subset of the lower ones, the the block which was evicted from lower level caches has to be invalidated. So for that, we make use of the back invalidate function. What it does is it checks for all the upper level caches, let's say the L2 cache or the L1 caches, and if there is an entry corresponding to the particular address which is being evicted from the last level cache, which is the LLC, we invalidate it.
Similarly for L2, like if it's
and
being
similarly,
invalidated, if it's being evicted from L2, we
if it's being
invalidate it.
evicted from L2, we iterate over all the CPUs over all the L1 caches, and we invalidate that address.
So this was the only change needed to convert the non-inclusive structure to the inclusive structure. Whereas for the exclusive structure, we need to do multiple changes. First of all was that in the non-inclusive structure, whenever a block is called from the memory, it's stored in all of the three caches, L1, L2, and LLC. What we needed to do was we needed to bypass the L2 and LLC caches. So for that, there was already a defined function LLC, which was only open when the LLC bypass term was defined. In that, we just changed the parameters for the term for the if condition, and that allowed us to bypass the LLC and L2 cache even whenever a new data was coming from the memory. Other than that, in the handle fill function itself, whenever we are evicting a function from the L1 cache, we need to put it in the L2 cache, irrespective of it being dirty or not. So earlier in the non-exclusive, if the evicted block was dirty, only then we put it in the L2 cache. So here we created another function dirty check, which is only applicable when the exclusive tag is on, and it just checks if the block is in L1 cache, and if it is, then
If it is being evicted.
and if it is being evicted, then it is put in the lower level cache, irrespective of it being dirty or not.
Yeah, so I'll explain what modifications we made to the second function for the cache data type. In write back, essentially, what the only change we needed to do was yeah, so in write back again the same thing. So suppose we got a block in the write back of of let's say an L2 cache, and if the write back is evicting some other block, then again we need to do the same thing, irrespective of it being dirty or not. We need to send it to the write key of the lower cache, and this happens only in the L1 cache because sorry, in L1 and L2 cache, because obviously in LLC there's no, I mean, write back, if it evicts a block, there's no need to write it to the main memory because it's always going to be present there. And we made only and in handle read we needed to make the following changes. So yeah, in handle read, so suppose let's say a block is being read into a cache from the read queue. The one thing that we needed to do was we needed to invalidate the entry only if the cache type was LLC or it was an L2 cache. And
this basically means that if we are reading, let's say we have a miss in the upper level cache L1 or L2, and we are getting a hit in the lower level cache L2 and LLC respectively, then the block should move from the lower level cache to the upper level cache. So for that, we just put into the write queue of the upper level cache, and we invalidate it in the lower level cache.
Recorded.